Hello students. So I welcome you all to the Shri Chaitanya Gosala channel and myself Manpreet Singh, and I'll be taking the long-term batches in this campus for long-term CO Missile 1 and CO Missile 2 batches. I'll be taking physics track 2 here, and other track will be taught by Harimohan sir. So, in this online class, we will discuss a very important concept, and that concept is actually related to vectors. So, if possible, you can tell me that is the voice and the audio and the video is clear or not, and then we can start our lecture. So today what we are going to do is we are basically going to discuss the concept of vectors. See, let me tell you, Harimohan sir started the basic mathematics part. He discussed all about basic mathematics. Yesterday he started the lectures. He will be taking all the trigonometry, the differentiation, integration part, and everything about that. And from here, parallelly, I will take vectors part. Now, these two topics, why we are taking, let me tell you. The reason is that these two portions, whether you talk about basic mathematics or you talk about vectors, these two portions are the most important topics if you want to start your physics journey. I know that you will be joining the long-term batches, so you might already know some things, but always remember that if you want to improve your physics to a very good level, then these two topics will play a very important role. So once your base is clear for vectors and for basic mathematics, then after that we can build on to the building, and our building will be very strong. So if our base is clear, then our building will be very good. So we are going to focus on that only. And now let me start the topic for you. So let's put the heading, and the heading is, first heading is scalar. So we will start from the very basic. I will explain you everything in detail. Each and every point I will explain to you, and then deliberately we will go on to the numericals portion. So we'll go to the from the basic level to the advanced level. We'll try to solve all the type of questions. Today will be mainly conceptual class, in which I will deliver all the concepts, and by day after tomorrow when I will take the class again, we'll discuss a lot of numericals based on that. Today also some numericals I will take. So what is a scalar? First of all, let us understand what is a scalar. So scalar is any quantity which does not have any direction. It only has a magnitude part, it does not have any direction. So any quantity which is not associated with direction, or it does not have any direction, is called a scalar. Very simple, let's write it down, a very simple quantity. And please, you can make notes as I am writing on the board. You can also make notes, and you can take help from these classes. So what is a scalar? Scalar is basically any quantity which does not have direction. Any quantity which does not have direction is basically called as a scalar quantity. Sir, can you give some examples of scalar quantities? You can tell me what are the different examples of the scalar quantities. So scalar quantities can be distance, they can be displacement, they can be speed. Displacement is basically a vector quantity, but distance, speed, all these quantities are basically scalar quantities. So we can write the examples. The example of scalars are distance, speed, etc. Other quantities can also be treated as scalar quantities, but these are few examples of scalars. The next topic which we want to discuss is vectors, which is the main topic which we have to discuss in this particular class. So what is vector? Any quantity which has magnitude, any quantity which has direction, and any quantity which obeys the rules of vector algebra, that particular quantity will be called as vector. Many people only learn two things. That vector means what? Vector means a quantity having magnitude and a quantity having direction. But if I say properly, this is not just the only definition of vector. Apart from this, whatever quantity you are calling it as vector, it should obey the rules of vector algebra. When I say the rules of vector algebra, that means it should obey mainly vector laws of addition, It should obey the properties of vector laws of addition like commutative law and other laws. It should obey dot product. It should obey cross product. So whenever I'm talking about vector algebra, then all these things I'm talking about. So any quantity which is obeying the rules of vector algebra and it has magnitude and direction, only that quantity will be called as vector. If a quantity only has magnitude and direction but it is not following the vector algebra rules, then we will not consider it as a vector. I'll take one example also. First, let me write all these things. So what is the first point? Any quantity which has magnitude and direction. Obviously, it has to have a magnitude, it has to have a direction. So both things are required. And the second point is that it should obey the rules of vector algebra. It should obey rules of vector algebra. It should obey the rules of vector algebra. So this quantity is basically called as what? This quantity is basically called as vector quantity. I hope it is clear to you. What are the different examples? Examples are many. In physics, we will discuss a lot of examples. First example is displacement. Then we can talk about acceleration. We can talk about momentum. And there are a lot of quantities which we'll discuss in this particular physics course which are treated as vectors. That is why we are learning this particular topic. Because in entire physics, we will learn about a lot of quantities which are basically vector quantities. That is why the first topic should be very clear. This vector topic should be very clear to you. Now, why I'm saying that it should obey vector laws of addition, just if it is having magnitude and direction, then there will be a problem. Why I'm saying like this? Suppose I take an example. Suppose I take current as an example. Let us suppose I say to you that there is a wire in which there is a 3 ampere current which is going. And let us suppose there is a wire in which there is a 4 ampere current going. And let us suppose there is one more wire here. So we very well know this is a very basic example that if 3 ampere current is going in this direction and if 4 ampere current is going in this direction, then obviously in this particular direction, how much current will go? In this direction, basically 7 ampere of current will flow. But tell me one thing, did you use the vector laws of addition or vector laws of algebra to discuss this 7 ampere? No. You directly calculated this 7 ampere by adding these two, just as you are doing a scalar addition. Is current having magnitude here? Yes. Is current having direction here? Yes. Magnitude also is there, direction also is there, but still you are obeying scalar laws of addition. You are adding these two currents by using scalar algebra. You are not using vector algebra here. That is why current has magnitude and direction, but still it is not considered as a vector. It will be considered as a scalar. Why? Just because that it will not obey the rules of vector algebra. I hope this particular point is clear to you. So I can say that current has both magnitude and direction, but still is considered as scalar. Still is considered as scalar. And the reason I already told you, because it is not obeying the vector laws of addition. I hope it is clear to you. So this was the basic understanding, the basic starting point of scalars and vectors. So I hope you have written this. If you have not written, please, I'm taking the board away and you can copy this and then we will move forward. Okay. Now let's come to the next concept, and the next concept is related to the representation of a vector. Sir, we know now what is a vector. You have told us the definition of vector, but how to represent a vector? Pictorially, how to represent a vector? So the next topic is representation of a vector. Representation of vector. If we want to represent a vector, then always remember any vector can be represented by an arrow. any vector can be represented by an arrow. This arrow has a tail and a head. This part of the arrow is called as tail, and this part of the arrow is called as head. So whenever you want to represent a vector, then it will be represented by an arrow. This part of that arrow will be represented by the tail, and this will be represented as head. The direction of vector will always be from tail to head. Tail can also be written as the initial point from where the vector is starting, and head can be written as the final point. So what will be the direction of vector? The direction of vector will be simply the direction from tail to head, or the direction from initial to final point. This is basically the direction of the vector. So I can write that direction is from tail to head, or I can say it is from initial to final point. Initial to final point. This is basically the direction. Sir, how to calculate the magnitude from this pictorial representation? Beta, that is also very simple. If I want to write the magnitude of the vector, so whatever is the length of this arrow will give me the magnitude of the vector, will give me the sense of the magnitude of the vector. If there is a vector having more length, then its magnitude is more. If there is a vector having less length, then its magnitude will be less. So magnitude will be represented by length of the arrow. Length of arrow. More bigger arrow, more length, more magnitude. Less length, less magnitude. So direction and magnitude I have told. Achha, one more thing. If I want to represent this particular vector mathematically, then how will I represent? Suppose this vector is a vector. So I represent the vector by a vector or p vector or f vector or v vector. I can represent by any letter. By any letter I can represent a vector. The only thing is how you will say that the letter is basically a vector quantity. You apply an arrow above. So if I say that this vector is a vector, then I will say that the vector is represented by an arrow whose direction is from tail to head and whose magnitude is given by the length of this vector. And length of the arrow can also be written as, or magnitude can also be written as, please understand, magnitude of the vector can also be represented as a vector mod. Whenever I apply a vector mod, that means I am talking about magnitude. And always remember, magnitude of the vector is always a positive value. Magnitude of the vector will always be a positive value. So it is always positive, and the magnitude is represented by what? Mod of a vector, and basically this is how the representation goes. If I want to write force vector, then I will write f vector. If I want to write momentum as a vector quantity, I will write p vector. If I want to write velocity as a vector quantity, I will write v vector. Whenever there is an arrow on any symbol or arrow on any letter, then that particular thing is called as a vector. So this is how you will represent any vector. I hope it is clear to you. Please, you can note it down and we can move forward. Okay, let's move forward. Let's come to the next concept, beta. So we have discussed representation of vector, we have discussed the definition of scalar, we have discussed the definition of vector, and now let us come to the next concept, and that next concept is basically related to what? That is properties of vectors. Properties of vector. So there are 4 to 5 properties which I want to discuss. Everything I will discuss in great detail so that you understand it carefully, and we'll go somewhat slow initially and then we will increase our pace. Pehle we'll go slowly. So first property of the vector. First property of the vector. Suppose you have a vector, let us suppose this is the head of that vector and let us suppose this is the tail of the vector. Suppose you have a vector in space. This particular vector in space can be shifted parallelly without changing its orientation. That means suppose there is a vector here and let us suppose I want to take this vector at this point. So I can take this vector at this point, there is no problem. But you should remember only one thing, that when you are translating this vector or when you are moving this vector in space, then the sense of direction should not change. If the direction is changing, then you will not call this as a different vector. Whenever you want to translate the vector or whenever you want to shift the vector, you can only shift the vector parallel to itself. So direction sense should not change, and obviously the magnitude should not change. This is a very important property. Any vector, if it is a free vector, these type of vectors are called as free vectors. Any vector which is in space and it is a free vector, it can be shifted parallelly in space, but remember one thing, its direction should not change, or it can be shifted only parallelly. I hope this is clear. Like, let us suppose if I draw a diagram, then this from diagram also it will be clear. Suppose I take a vector, a vector. If I want to shift this vector parallelly, what I will do? Very simple. I can do this particular concept. I can shift this particular vector like this. So this vector and this vector are one and the same thing. I can shift it more. Suppose I shifted one more time. Let us suppose I parallelly shifted here. So can I say all these three vectors are similar? Yes. All these three vectors are equal. You can shift the vector parallelly in space without changing its direction. Every vector will be represented by the same vector. This is also a vector, this is also a vector, this is also a vector. There is no problem. The only thing is what I said, that direction should not change. ये ऐसे rotate नहीं करना चाहिए. This should not change. It should remain like this only. And magnitude also should be fixed. Let us write it down. लिख लेते हैं इसको. So, a vector can be shifted. A vector can be shifted parallelly without changing its direction. Without changing its direction. A very important property, and we have clearly discussed what is basically the first property. Let's go to the next property. Let's go to the second property of this. The second property is, whenever I want to discuss about a vector, suppose if there is a vector A vector here, and let us suppose if I rotate the vector by an angle theta, please understand, suppose if there is a vector A vector here, and let us suppose if I rotate the vector by an angle theta, then basically what is happening is the new vector and the old vector one and the same vectors? No. What has changed? Has the length of the vector changed? No. Has the magnitude of the vector changed? No. When you rotated this particular vector, the first thing which has changed is the direction of the vector. And because whenever we are talking about vector, then there is a magnitude also and there is a direction also. Even if one of the things changes, then we say vector changes. Here the magnitude is not changing on the rotating the vector, but the direction of the vector changes. That is why this new vector and this old vector are not the same vectors. We have said that vector changes. I hope it is clear to you. So let me write that point also. Let us suppose I am having a vector here, and I rotated this vector by an angle theta such that my new vector became b vector, and this is the angle of rotation. I rotated the vector by this much amount, by this angle, and now the vector is b vector. Initially it was a vector. Is the magnitude of a vector and b vector same? Yes, magnitude is same. But are the vectors equal? No, the vectors are not equal. A vector is not equal to b vector. Why a vector is not equal to b vector? Even though the magnitude is same, the direction is different. So I can say that if a vector is rotated, by an angle theta other than integral multiples of 2 pi, then vector changes. I have written a word here, a very important statement I have written. See here. I have written a very important statement that if a vector is rotated by an angle theta other than integral multiples of 2 pi. What is the meaning of this? Other than integral multiples of 2 pi. The meaning is that basically if there is a vector, a vector, and let us suppose if I rotate it by 360 degree, or if I give it a 1 turn, 1 full turn, then will the vector come to its original position a vector? Yes. If I give it 2 rotations, that means multiple of 2 pi. 1 rotation corresponds to 2 pi angle, that is 360 degree. If I give it 2 turns, then again it will come back to its original position. If I give it 3 turns, again it will come back to its original position. So what I am trying to tell, that if any vector is rotated other than integral multiples of 2 pi, that means integral multiples of 2 pi should not be there, because if integral multiples of 2 pi will be there, the vector will come back to its original position. And we will say that the vector is same then, because magnitude also is coinciding and direction also is coinciding. So if you are rotating the vector but the angle is not integral multiple of 2 pi, then only we will say that the vector changes. Otherwise the vector will remain same. So this point has to be noted down. I hope it is clear to you. So this was the second property which we discussed. Now this brings me to the third property which is linked to this. The third property is equality of vectors. The third property is equality of vectors. What do you mean by equality of vectors? When do I say that 2 vectors are equal? Very simple. Please understand very carefully, 3 points are there and generally people miss the third point. All the 3 points, if they are matching, then only we will say that 2 vectors are basically equal. Otherwise, the 2 vectors will definitely not be equal. So what are the 3 properties? First, whenever 2 vectors are equal, first property is magnitude should be same. Second property, direction should be same. Third property, both the vectors which you are saying they are equal, both the vectors should obey, both the vectors should represent same physical quantity. The third property is very important. Generally people miss this, generally students miss this particular property. Always remember, whenever you are saying 2 vectors to be equal, magnitude should be same, direction should be same, and they should represent the same physical quantity. If I say there is a vector which is represented by force vector, and if I say there is a vector which is represented by momentum vector, let us suppose I say that the direction of momentum and the direction of force are same. The magnitude of force and the magnitude of momentum are same. Are these 2 equal vectors? No, these are not equal vectors. Why? Because even though magnitude and direction is same, but still the direction of the force and the momentum are 2 different physical quantities. That is why we will not say that this particular 2 vectors are equal vectors. I hope this particular point is clear to you. So let's write this particular point, that whenever I say that equality of vectors, then I say that A vector will be equals to B vector if A vector will be equals to B vector if, first point, magnitude of A is equal to the magnitude of B. Second point, the direction of A and B vector should be same. The direction of A and B vector should be same. And the third point is that they should represent same physical quantity. They should represent same physical quantity. So this is a very important concept. Whenever you are talking about this particular equality of vectors, magnitude should be same, direction should be same, and they should represent the same physical quantity. I hope this particular point is clear to you. Let's go to the next concept. Let's go to the next property, angle between the vectors. And this is also a very important property, angle between the vectors. Angle between the vectors. How to write the angle between the vectors? Always remember, whenever there are 2 vectors and you want to find the angle between them, then first make it very clear that either you join their tails. What is the meaning of tail? I represented it. Tail means this point, head means this arrow. So whenever you are having two vectors and you want to find the angle between those two vectors, always remember that first you have to join the tail of two vectors. If it is already joined, there is no problem. If it is not joined, then you can shift the vector parallelly, because that is an allowed operation. You can shift the vector parallelly and then you can find the angle between the vectors. So always remember, shift the vector parallelly, join the tails of two vectors, then whatever is the smaller angle between those two tails or those two vectors, that will be represented by the angle between the vectors. So let me give you an example so that you understand. Let us suppose I say to you that this is one vector, A vector. And let us suppose I say that this is another vector, B vector. Are the tails of the two vectors joined? Yes, definitely. The tails of the two vectors have been joined. So there is no need to worry. Right now you can directly tell that the tails of the two vectors are joined. I can say that this will be the angle between the vectors. And I will represent it like this. Theta is basically the angle between A vector comma B vector. A vector comma B vector angle is, this is the representation of angle. Angle between A vector and B vector is basically theta. I hope it is clear to you. If it is clear, please let me know in the comment section if all the things are being clear to you. So this is basically the angle between A vector and B vector. But let us suppose, if I say to you, let us suppose this angle is 30 degree. So the angle between A vector and B vector is how much? The angle between A vector and B vector is 30 degree. There is no problem. But now let us suppose I say to you that I have a vector A vector and I have a vector B vector. And let us suppose this angle is given as 60 degree. Now please tell me one thing, that is the angle between A vector and B vector equal to 60 degree? Please tell. That is the angle between A vector and B vector 60 degree? The answer will be no. A vector and B vector angle is not 60 degree. Because what I told just now, that whenever you want to find the angle between the vectors, first you have to join the tail of two vectors. How to join the tail of two vectors? It is very simple task. Either you can shift this vector B vector and you can join the tail of A vector with B vector, or what you can do is you can take this A vector, you can shift parallelly this vector ahead and then you can find the angle. So कैसे calculate करना है? I will draw B vector like this only, and what I will do is I will shift this vector ahead so that the tails are connected together. Which angle was given to me? This angle was given to me. This angle was given to me as 60 degree. If this angle is given to me as 60 degree, then the angle between the vectors will not be 60 degree. The angle between the vectors will be this angle. And this angle is nothing but, total angle is 180 degree. On a line, the total angle is 180 degree. So 180 minus 60 will be giving you how much? It will be giving you 120 degree as the angle between A vector and B vector. A very simple, a very subtle concept and a very beautiful concept. Whenever you want to find the angle between the vectors, always first you have to join the tails of the two vectors and then you have to calculate the angle. Don't just blindly go for this answer. 60 degree is not the answer for this. 120 degrees is the answer. I hope it is clear to you. One more thing. Either you can join the tails of the two vectors or you can join the heads of the two vectors. From both you will get the same answer. And always remember, whatever theta you will get, angle between the vectors, if it is theta, then theta will always be between 0 degree and 180 degree. Always theta will lie between 0 to 180. Whenever you are finding angle between the two vectors, the angle between the two vectors will be between 0 degree and 180 degree. And this particular angle can be calculated by either joining the tails or either joining the heads. That is your choice. So what I am doing is I am taking few examples. Please try to attempt those particular questions and then we'll move forward. Okay? I hope this is clear to you. Please note it down, whatever you want to note, and then we will go forward. And then I am giving you few examples. Chalo, Let's move forward. Let me give you one question. Okay, let me give you one question. Please try to attempt it. Whosoever is watching, please try to attempt this particular question and give me the answer in the chat box. Suppose I have three vectors, A vector, and I have B vector, and I have C vector. These are my three vectors, A vector, B vector, and C vector. Let us suppose they are making an equilateral triangle. Or I can say that the magnitude of A vector is equal to the magnitude of B vector is equal to magnitude of C vector. So obviously if the magnitudes of the three vectors are equal and they are making a triangle, then obviously they are making an equilateral triangle. If they are making an equilateral triangle, I can say that the angle between the angle here all will be 60 degree. This we already know. Now my question is, find angle between A vector and B vector, angle between B vector and C vector, and angle between C vector and A vector. I want to find this angle. Angle between A and B, angle between A and C, and angle between B and C. So if you have understood, please try to attempt this question and give me the answer in the chat box. Please tell. Angle between A and B, angle between B and C, angle between C and A. I want to know what is the angle between the two vectors. If possible, please try the question and give me the answer. Always remember, whenever you want to find the angle between the vectors, it is always the angle between the tail to tail. First you have to join the tail to tail, then only you can give the answer. So if you want, you can give the answer and then I will do. Okay, so let's continue forward. What we can do is, see here, this angle will be 60 degree, this angle will also be 60 degree, and this angle will also be how much? 60 degree. But if it is an equilateral triangle, then all the angles will be how much? All the angles will be 60 degree each. Because all the angles are 60 degree each, what I can do is, I can first concentrate on A vector and B vector. Is the angle between A vector and B vector 60 degree? No. The angle between A vector and B vector is not 60 degree. The angle between A vector and B vector, if you want to find, then you have to shift this particular vector here. You have to shift this vector here. Then only you can find the angle between the two vectors. So for A vector and B vector, what I will do is, I will draw the diagram again. This is my A vector. I shifted this vector ahead and this is my B vector. And this was the angle 60 degree. So if this is 60 degree, this will be 120 degree. So the angle between A vector and B vector is actually equal to 120 degree, not 60 degree. I hope it is clear to you. Next is to calculate the angle between B vector and C vector. Now it is a tough task. Is the angle between B vector and C vector 60 degree? Not at all. Because here also you are joining head to tail. But whenever we want to calculate the angle, we have to join tail to tail. So what we are going to do is, we are going to shift this vector ahead. So again I am drawing the diagram. Please see here. C vector will be like this only. This is my C vector. This is like this only. B vector I will shift it upwards so that tail to tail is joined. This is my B vector. And this angle was given to you as 60 degree. If you see properly, this angle was given to you as 60 degree. So this angle will be how much? This angle will be 120 degree. So that means the angle between B and C will also be equal to how much? The angle between B and C will also be equal to 120 degree. And now let us concentrate on C vector and A vector. Will the angle between C vector and A vector equal to 60? No, not at all. Because C vector and A vector also head to tail is joined. We want to join tail to tail first. So what we will do? Again we will come here. This is A vector. I will I will shift this vector parallelly so that this tail is joined with this tail. So this will be my C vector. This angle was given to me by 60 degree. So this angle will be how much? This angle will be 120 degree. This angle will be 120 degree. So I will say that the angle between all these three vectors, which was appearing to be 60 degree, is not actually 60 degree. It was appearing to be 60 degree. The angle between all these three vectors is actually 120 degree. I hope this particular point is clear to you. So this was the third case which we wanted to discuss. So understood the property? I think now it is understood that whenever you want to find the angle between the vectors, always you have to join the tail to tail or the head to head, and you will get the answers to this particular question. So this was the fourth property which I wanted to tell. And one is the last property. I am writing it here only. The last property I am writing it here. Whenever I compare two vectors, is vector inequality defined? Please tell. It vectors inequality defined or not defined? Vectors inequality is never defined. We will never say A vector is greater than B vector or A vector is lesser than B vectors. No. If somebody is saying to you that please there are two vectors, whose vector is more than the other vector? You will say to him, Bhaiya, this inequality is not defined. This is not a valid operation in vectors. Inequality of vectors is not a valid operation in vectors. If you want to compare vectors, you can only compare the magnitudes of the vectors. There is no concept of vector inequality in the case of vector algebra. So very important point, let me write it down, that inequality of vectors is not a valid operation, or we can say inequality of vectors is not defined in vectors. So I will never say this particular word that A vector is more than B vector or A vector is lesser than B vector. Not at all. I can compare magnitudes. Magnitudes I can compare. Directions I cannot compare. So these were the 5 most important properties of vectors, and these properties will be used. When I will discuss questions in the next class, I will use all these properties. I've already discussed few examples of angle between the vectors, but I will also discuss few properties. When I will discuss some questions, I will use these all properties. So I am repeating it again. Okay, I am repeating all the things again. Please listen to me very carefully. All the things I am repeating it again. The first property was what? Quickly I will conceptualize and I will recall all the things for you. What is the first property, beta? The first property is whenever there is a vector and that vector you are shifting parallelly, then you can shift the vector parallelly in free space anywhere. The only thing you have to remember is that the direction of the vector should not change and the magnitude of the vector should not change. This was the first property. The second property was that whenever you rotate a vector by some angle, and that angle is not an integral multiple of 360 degree or integral multiple of 2 pi, then we say that the vector is changed. B vector is not equal to A vector, even though the magnitude of the vectors are equal. But because the direction has changed by rotating the vector, the direction is changing. That is why B vector and A vector will be different. So what I said, if a vector is rotated by an angle theta other than integral multiples of 2 pi, then I will say that the vector changes. This was the second most important property. The third property, equality of vectors. Third property is equality of vectors. When I will say that A vector and B vector are equal, I will say A vector and B vector are equal when three things should be understood very carefully. Three things should be kept in mind whenever you say A vector and B vector are equal. The first is that magnitude of A vector should be equal to the magnitude of B vector. The second is that the direction of both the vectors should be same. And the third most important point, which many students forget, is that both the vectors should represent the same physical quantity. They should represent the same physical quantity. That is the most important point. The next thing is, the next property which I discussed was the angle between the vectors. In this you have to remember few things. Whenever they are asking you angle between the vectors, first you have to take care of it that you have to join the tails of the two vectors, or you have to join the heads of the two vectors. And then after that, then after joining the tails or the heads, whatever angle you are getting, that will be represented by the angle between the vectors. And that angle will always be between theta is equal to 0 degree to 180 degree. So between 0 and 180 degree, this angle will lie. And I gave some examples also to make you understand this particular concept. And the last point which many people make a mistake, they compare vectors. Not just students, some teachers also, they compare vectors. That A vector is more than B vector or B vector is more than A vector. Always remember, inequality is never defined for vectors. You can compare the magnitudes of the vectors. Magnitude of A vector can be more than the magnitude of B vector or less than magnitude of B vector. That can be possible, but vector inequality is never defined. So I hope this particular concept is very much clear to you and it is ingrained into your mind. So these were some properties of vectors. Now let me move forward. I think you might have written all these things. Let me move forward and let me discuss a very important vector, that is unit vector. Very important vector, and that vector is called as unit vector. What do you mean by a unit vector? And why there was a need of unit vector? So unit vector represents what? But a unit vector represents direction. Simple, plain and simple. Unit vector is a vector which represents the direction of the vector. Sir, what do you mean by that? Suppose I say that there is a force of 5 Newton acting towards east. There is a force of 5 Newton acting in the direction of east. Then what is the magnitude of this vector? You will say that, sir, magnitude of the vector is basically 5. The length of that vector or the magnitude of the vector is 5 Newton. But force is not just associated with magnitude. It is associated with direction also. So magnitude is 5 Newton. Direction is towards east. That direction which I am telling you towards east, that direction is unit vector. Unit vector of that force is basically a direction towards east. Sir, what will be the magnitude of this unit vector? Because unit vector is also a vector only, na? So it has to have a magnitude also. Always remember, magnitude of a unit vector will always be unity or 1. The direction of unit vector will be the most important thing. So let me write it down. Very important point. What is the unit vector? Any vector which has a magnitude of 1 unit, any vector which has a magnitude of 1 unit and it represents direction of a given vector. It represents direction of a given vector. Then we call that vector as unit vector. Simple terms, what is a unit vector? If somebody will ask you, 2 things you have to remember. What is the magnitude of the unit vector? The answer is 1. Sir, what is why it is important for us? What is the significance? The significance is that this particular unit vector represents the direction of the vector. And any vector has 2 components, magnitude and direction. So whenever I want to write any vector, suppose I want to write a vector, A vector. How can I represent this particular vector? I will represent this vector as magnitude of A vector. Magnitude of A vector multiplied by the direction. And direction is given by the unit vector of A vector, that is represented by A cap. So I will say A cap is basically unit vector in the direction of A vector. Whatever is the direction of A vector, to represent the direction of A vector, I will write it by unit vector A cap. So any vector A vector can be written as what? The multiplication of 2 things, magnitude of the vector multiplied by its unit vector. So from here I got the definition of unit vector also. Definition bhi aa gayi hai. What is the definition? that any unit vector can be represented by a vector divided by its magnitude. Any unit vector can be represented by, beta, please understand very carefully, any unit vector can be represented by the vector divided by the magnitude of that vector. A vector divided by its magnitude. This is called as the unit vector in the direction of a vector. I hope it is clear to you. Let me take examples. So that you understand this concept, how I have to find unit vector and how this vector can be written as magnitude of a vector multiplied by a cap. Let me give some examples. See here. Suppose I take one example that force vector is 5 Newton towards east. Force vector is 5 Newton towards east. Sir, how will I write the unit vector of force? I will say, beta, unit vector of force is F cap. Always remember, unit vector is always represented by a cap. So F cap I want to find. Kaise likhunga? What I told F cap can be written as what? Vector divided by its magnitude. So vector is basically F vector divided by the magnitude of F vector. Sir, what is F vector? Beta, F vector is this complete term. 5 Newton towards east. 5 Newton towards east. What is the magnitude of force? Magnitude of force is 5 Newton. So this 5 Newton will cancel with this particular 5 Newton. These will cancel out and I will get the unit vector as the direction only, and that direction is towards east. This is the unit vector of this given vector. Now always it is, if I want to write always the direction of unit vector is basically towards east, I'm writing it in English terms. But I want to be more specific. I want to write very small terms so that in my mind it is clear that if I write this particular number or if I write this particular unit vector, then this unit vector represents this direction. तो उसको लिखने का तरीका क्या है? Please understand. By default, 3 unit vectors should be very much clear to you. Suppose this is the x-axis, this is the y-axis, and this is the z-axis. This is minus x-axis, this is minus y-axis, and this is minus z-axis. Actually, z-axis is coming out of the plane. If this is my plane, this is x, this is minus x, this is y, this is minus y, then this vector out of the plane will give you z, and into the plane towards me will give me minus z. Out of the plane towards you will give you z, and into the plane will give me minus z. Whenever I am moving in the positive x direction, then the unit vector for positive x direction is plus I cap. Whenever I am moving in the negative x direction, I will say minus I cap. In positive y direction will be plus j cap. In negative y direction will be minus j cap. If I am moving in the z direction, it will be plus k cap. And if I am moving in the minus z direction, it will be minus k cap. So because unit vector is representing direction, so 6 directions unit vectors you should know. At least these directions you should know. Other directions we will understand by taking the concept of the different unit vectors. But at least these unit vectors you should be very careful. So there are 6 unit vectors which I want to know. The 6 unit vectors are what? In the positive x direction it is plus I cap. That means whenever I am moving in the positive x direction, that particular unit vector will be represented by plus I cap. That means whenever I will give you the information that any particular force or any particular momentum or any vector is in positive I cap direction, you should get a feeling that the direction of that particular vector quantity is in positive x direction. Whenever I am representing it in negative x direction, that unit vector is minus I cap. In the positive direction is plus j cap, in the negative y direction is minus j cap. Out of the plane, out of the board it is plus k cap, into the board it is minus k cap. So these 6 particular directions should be very careful to you. Let me take one example so that you understand this particular concept. Let me take one example. So let us suppose I said that velocity of particle, the velocity of particle is 20 meter per second towards east. Let us suppose I said to you that the velocity of the particle is 20 meter per second towards east. So velocity is a vector quantity. And for vector quantities, I want to know two things. One is magnitude and one is direction. Do I know the magnitude of the vector? Yes. The magnitude is 20 meter per second. Do I know the direction of this vector? Yes. It is towards east. But now I want to represent it mathematically in terms of I cap, j cap. So how will I represent? Achha, by default, please remember, east direction is by default I cap, west direction is by default minus I cap. North direction is by default j cap and south direction is by default minus j cap. So when I represented velocity of the particle, how will I write? Please understand. Any vector can be written as magnitude of that vector multiplied by its direction, which is given by its unit vector. The magnitude of the vector is how much? The magnitude of the vector is 20 and the direction of the vector, I told you already, east direction represents what? I cap. So directly I can write that the velocity is 20 I cap and 20 I cap meter per second. Because unit also you have to specify, no? So 20 I cap meter per second will give you the complete information about this particular vector. One more thing, very important point, direction never has a unit. Direction does not have a unit. Don't say that, sir, I cap is having any unit. This unit is always associated with the magnitude part, not the direction part. So I will say, how will I interpret this particular information? If somebody gives me the information that the velocity of the particle is 20 I cap meter per second, I will say that the magnitude of the velocity is 20 meter per second and it is going in the east direction, in the positive I cap direction. I can take one more example so that you understand it very carefully. Let me say that displacement of a particle is 6 meter towards west. Displacement of the particle is 6 meter towards west. I want to represent this particular information, but vectorially I want to represent with the help of I cap, j cap, and I want to get the complete information about this. How will I do it? Please understand. First of all, displacement is written as S vector. Any vector can be represented as magnitude of that vector multiplied by its unit vector. Unit vector represents direction. How will I write this displacement vector in terms of I cap and j cap? What is the magnitude of the vector? Displacement of the particle is 6 meter. So the magnitude is 6. And where is the direction? It is towards west. What is the unit vector along west direction? It is minus I cap. So I will say that the displacement of the particle is 6 minus I cap. Or in simple terms, I can write it as displacement vector is equal to minus 6 I cap meter. Again, I am telling you, meter is associated with what? Unit is always associated with magnitude of the vector. And direction does not have any unit. I hope it is clear to you. One more thing, many people, if I write displacement vector as minus 6 I cap, many people think that the displacement is minus 6 meter. No, beta. Magnitude of the displacement can never be negative. Magnitude of any displacement can never be negative, or any quantity, magnitude of any vector is always a positive quantity. Minus 6 I cap is specifying you that it is in the magnitude of that vector is 6, but the direction is minus I cap. That is the correct representation of writing a vector or thinking about a vector. Now this was only in one direction. When the particle was moving only in I cap or only in j cap. I can represent vector in two directions also. Suppose I say that, let me take one more example, the last example let me take, and then we will wrap up the class. Please understand. Suppose if I say to you that displacement of a particle is 5 meter towards east, 5 meter towards east, and then 10 meter towards north. 5 meter towards east and then 10 meter towards north. They are asking you to find the displacement vector. So here two directions are included now. Initially he is going towards east by traveling a distance of 5 meter, and then he is traveling towards north by traveling a distance of 10 meter. So how will I represent this vector? Understand it very carefully, and this particular example will be the base for the next particular topic. When I will meet in the next class, I will start vector addition with you, and in that vector addition, I will actually give you the proof of the concept which I am telling you. So how to write this displacement vector? First, let us understand. Suppose this is east, this is west, this is north, and this is south. I already told you north is represented by j cap, south minus j cap, east is I cap, and this is minus I cap. Suppose I am going 5 meter towards east. So I will say 5 meter I traveled towards east. Then I am going where? I am going 10 meter towards north. From here I am going 10 meter towards north. I started from here. I ended at this point. What will be my displacement vector? So in the starting part of the class, I told you that whenever you want to write a vector, it always has an initial point and it always has a final point. What is the initial point of that? Initial point is this. It started from here. Final point is where? Final point is this. So I will say that this is my initial point denoted by I. This is my final point. So my displacement vector will be a vector joining initial to final point. This will be my vector joining initial to final point. And this particular vector will be called as my displacement vector. This is called my displacement vector. Now, how to write this particular displacement vector? I want to write this displacement vector. How will I write? Always remember, I want to reach at this point. Either I can go directly to this point, or I can go first in I cap, then I can go in j cap. So I will write for this vector, for this particular vector, I will write 5 I cap. What do you mean by 5 I cap? Again tell, 5 I cap means you are moving 5 meter in which direction? Positive I cap. Positive I cap means what? East. Yes, some people have given correct answer, but always remember, beta, beginning thunder, you have only given the magnitude of the vector. Your answer is correct, but answer is not complete. Answer is incomplete. Only you have given the magnitude of the vector, and that is perfect. Direction of the vector also you want to give. So how you will get the direction? 5 I cap, and then you are going in the direction of north. So it will be 10 j cap. 5 I cap plus 10 j cap will be the displacement vector of this quantity. This is the displacement vector. Now you might think that, sir, why you have added 5 I cap with 10 j cap? By which principles you have done this? How you are adding 5 I cap with 10 j cap? So that I will tell you in the next class when I will discuss vector addition with you. I'll discuss vector addition with you, and in vector addition I will tell you how you have to add these two vectors. Once you know how to add these vectors, you will be able to write this. Once you will be able to write this, you will be able to calculate magnitude, direction, everything about a vector. So that I will tell you in the next class how to do it. So I hope this particular class was useful to you. I tried to explain a lot of concepts in this particular class, and we are going with the very basics. I'll always start from basics. We are always going from the basics. Once your basics are clear, day by day we will increase. Next lecture will be a very good lecture in which we will discuss the vector laws of addition, and we will discuss how we have written directly this, how to calculate the magnitude of displacement. All these things we are discussing in the next class. So I hope you like this particular lecture. If you like this lecture, please give it a thumbs up. Thank you. We'll meet in the next class. Thanks a lot.